Geothermal heat pump. Water of refrigerate moves on the loop of a pipes. When the weather is cold, the water or the refrigerate heat up as it travels throughout the part of the loop that's spread on the ground. Once it gets back above the ground, the water transfers heat to the building. The water cools down after its heat is transferred. It is then come back under the ground where heats up once more, starting the process again. On the hot day, the system can run in reverse. The water cools the building and then it pumps under the ground where extra heat is transferred to the ground around the pipes. The great thing about geothermal heat pumps as opposed to geothermal power plant is you don't need to near liquid hot magma or geothermal hotspot.
First step in making energy in geothermal power plant is to drill a hole down to the superheated water. Step 2 is to bring the hot water up and let it release steam that turns into turbine. Step 3. The turbine is attached with a magnet and generator making an electrical current. Now, electricity can be put and bring to the people's house and business and schools. The water can be go to the cooling tower where then cool down and go back to the earth and injection well. Its turbine or pump down into the giant swimming pool.
Geothermal energy options.
How it works. Geothermal heating and cooling works by having into the constant heat source that is found 5 feet below the Earth's surface, and in the northeast, this temperature is approximately 53 degrees. Direct exchange has outperforms water source geothermal systems by 25%, most efficient system on the market. That's because DX does not require electrical circulators which use additional electricity. DX only requires one heat transfer, and DX utilizes copper piping has superior heat transfer properties tuning of water-based systems. Our equipment and installation are always separate as everyone else.
We drill our holes to a depth of 100 feet. When drilling to 100 feet, we're very tuned, encounter waste soil and wear on conditions, which are referred to conductivity. Each hole is drilled vertically and is spaced 7 feet apart. This prevents phenomenally ground loop interference. Efficiency. Each hole has 7 diameter cylinder that uses this area to gather Earth's energy.
When ground spaces is concerned, as land configuration can be used to reduce the area for drilling. Notice to reduce the surface needed at the top of the portholes. Here is the simplified on how heat pump works when heating your home. All heat pumps have compressor and an expansion valve that manipulates refrigerant. A refrigerant has two phases, gaseous and liquid. Refrigerant works on the basic principle that if you raise the pressure, you raise the temperature. If you lower the pressure, you lower the temperature. This is done by the compressor and the expansion valve. Let's say that refrigerant starts its journey and its gaseous state and compressor at 30 degrees. The compressor compresses the gas, which increases the pressure and raises the pressure to 160 degrees. The refrigerant travels through coil where fan blows cross. The air blowing across this coil absorbs the heat energy and distributes throughout home. As the refrigerant leaves the coil, it condenses back to its liquid state and moves toward the expansion. At 85 degrees, the expansion valve is basically like dam with a small note. When the refrigerant passes through the expansion valve, the pressure rapidly decreases. The temperature falls to 20 degrees.
It then moves toward to the TXV valves. These valves controls the amount of refrigerant distributed to each ground loop. The refrigerant is then piped out to the well-filled and down vertical portholes where begins transformation back to the gas. As it transitions back, as should stay, it absorbs heat energy from the earth and travels back to the compressor, where thus ingenious process repeated. When cooling is desired in this process is reserved.